So you can notice that it's the same position, it's the same objects, but it's completely different scene. You saw there is a house on the left. Now there are different houses on the right, on the left. There is a house on the right. There is a different house on the right here.
Hello and good morning, everyone. I'm Dr. Satya Malik, CEO of OpenCV. We have talked a lot on the show about data augmentation and how it can supercharge machine learning datasets in a cost-effective and scalable way. Today, we are excited to show a completely new concept in data augmentation, which we are calling generative data augmentation. It's a new tool called KopiKat that is brought to you by OpenCV.ai, the consulting arm of OpenCV. Anna Petrovicheva, the CTO of OpenCV.ai, is our guest to show off this awesome new tool, which is live at KopiKat.co. Anna, welcome back.
Hello, everyone, and thank you for joining. Thank you, guys. So I'm going to share my screen.
Before we begin, I have to introduce our Director of Content and Creative at OpenCV, Phil Nelson, who organizes the show. And if anything goes wrong, it is his fault.
That's right, Satya. Good morning, everybody. A quick RIP in the chat for the late, great Jerry Springer, who passed away today, the king of trash TV. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you can call me Phil, and I'll be your Huckleberry. But first, I'm here to remind you of a few things we do every single week here on OpenCV Weekly Webinar, the first of which is a special giveaway to you in the audience. Stay tuned. Later in the episode, you will get the opportunity to answer a trivia question here in the Zoom chat at opencv.live to win the OpenCV course of your choosing. Stay tuned for that later in the episode. We're also taking questions from you in the audience, and we will do our best to answer them. Use the Zoom Q&A button at the bottom of the screen or ask it in the chat window wherever you're watching. I'm monitoring that, and I'll do my best to bring up those questions as I see them come in. That's all from me right now. Satya.
All right, Anna, welcome back. Please introduce yourself, a short introduction, and then you can share your screen and we'll rock with the presentation.
Sure. So yeah, Anna Petrovicheva, I've been with OpenCV for a long, long time, and you probably saw me if you joined a couple of past episodes. And I would be happy to talk a bit about the product that I love, the product that we created recently in OpenCV.ai. And I hope that you guys will find it useful or ask me a lot of questions about it. So yeah, I was going to talk a bit about KopiKat. But first, let me just speak a bit about why we actually created it. So I'm the CTO at OpenCV.ai, the consulting arm of OpenCV, where we work with different companies from all over the world to bring computer vision and artificial intelligence algorithms, the state-of-the-art algorithms, to real production. So our typical pipeline is we work on the data set that is targeted to solve some specific problem, for example, defect detection on manufacturing side, or analyzing how fruits are performing in real life environments, or something that is happening in surgical rooms in different hospitals, right? So we collect the data set together with the customer, then we train the neural network, and then we report the neural network to the production device. So surprisingly, maybe not surprisingly, but many years ago, we started noticing that the most complex part and the longest part, the most, the part that brings a lot of nerves into the project is not the part when we create the neural network, but rather the part when we collect the data set and nail down the data set together with the customer. And it's probably the most important part, because the data set that we introduced to the project is like, without it, the project is nothing, right? We won't be able to solve the problem when there is no data to train the neural network on. So it's really, really important part. So
I also feel, Anna, that sometimes, when people are just joining the field, they're novices, there is this idea that, people try to change the neural network itself, the architecture of the network, to get better results. And it is almost never the case that, let's say you're using a modern architecture, YOLO v5 for object detection, etc. You can almost never get you get marginally get, small amount of improvements if you go to YOLO V8, right? On the other hand, if you spend the time with data, with augmentation and with cleaning up the data, you can get much more, benefits by just doing that. And that's the idea of data-driven, training, which a lot of people have embraced, but still when people are new to the field, they do not realize the importance of cleaning up the data and augmenting the data, right?
There is this famous slide from Andrei Karpathy when he was AI director, like the head of AI at Tesla, right? That when he was then when he was a postdoc and he was doing science, he was doing scientific research. He was most worried about the algorithms, right? He lost a lot of sleep over the algorithms, not around the data. But when he started working with real life projects at Tesla, it completely shifted, the priorities shift, and there is this gap between research and production. In production, data is the king, and there is no wrong, there is no other way to put it. Data is the most important part.
Right.
So we thought
there's an even older saying, which is garbage in, garbage out.
Yeah.
Yes. And I mean, no, exactly. So no matter how good your network is, no matter how big your transformer will be, it will just learn the garbage. So we tried to understand what can we do to make this process easier. So we totally understand that we need some data to train the neural network, but maybe there is a way to decrease the amount of data that we can collect to train the neural network. There is another thing that is specifically hard in real life environment. Imagine that you are training an autonomous driving algorithm, right? And you want to make sure that it works in all the possible environments. So it works in the sun, in the rain, or in the snow. You would need to collect hours and hours of this data in all these different environments and emulate just the same scenarios like pedestrians, motorcycles, bikes, everything. And it creates a lot of complexity in this project. Imagine that you would only need to collect the data set in one specific environment, for example, in the sun, and you would do something with our algorithm that would enable you to recreate just the same data set as if it was collected in the snow, in the rain, or other environments. So this was our core idea. And this project that I'm going to talk about is also motivated in a big part by the huge boom in AI that we are experiencing right now with the generative neural networks, and it is using generative neural networks inside heavily. So let me show you how it works. First, let me actually go to the site. I'm going to share my screen and go to this site. Here, it's KopiKat.com.co. Yep. I click the upload button and I select an image from my computer. It's going to load. Wait for a second. So it's a bus, as you can see here. It's like a small image, but still, it's a bus. There is some green grass and a mountain in the background. Then I just type my email, which is anna@opencv.ai, and click generate. So it typically takes several minutes to generate. However, sometimes a lot of people are attracted to our site and it may take just a bit longer, but the results will hit your email. And I'm going to show you what I got when I already sent an image just like this one. So remember the image that we saw on the previous screen?
Some of these, the techniques are computationally very heavy, and that is why, when Lensa actually created, Lensa is an app where you can upload 20 pictures of yourself, and it will create, 200 virtual images of yourself, where you have many different things. So, but that takes about 20 minutes to return the results. And that is why, we basically to close the session, we are asking for the email address. You get it in your email. You don't have to wait there a few minutes because, eventually these things will get way faster. but right now it does take a few minutes.
Exactly. So we just launched
Yep.
this site very recently, and we are collecting a lot of feedback. We are working on improving the site.
Yep.
And this is why we are doing that. So we are returning the results to your email so that you have all the time to go to your email, review the images, like click and zoom, and don't have to refresh the page to wait once it's done. So this was the image that I used to upload on the site on the previous screen. And here are the results that I got. So I got the same, so you can notice that it's the same position, it's the same objects, but it's completely different scene. You saw there is a house on the left. Now there are different houses on the right, on the left. There is a house on the right. There is a different house on the right here. And it's in winter, even though the first one was taken, well, probably it's a cloudy summer or maybe autumn, something like that. So next image was like that.
Oh God, this looks so good.
So it's a rainy image from a summer day. This one probably with the fog, right? There's definitely some
It's
fog.
like Mordor back there in the back. There's you see some hobbits climbing that mountain back there.
Sunny day here. One more day like that.
Or possibly the Misty Mountains for you Tolkien nerds.
How many images are sent back, Anna?
6 images.
6, okay.
6 images are sent back. So there is also an option to talk to have a call with us and get any number of images that you want, right? So you upload like 1,000 of images, and we return 6,000 of images or 10,000 images of images. We are doing that. But on this site as a demo, you get 6 images from one image that you send.
Yeah,
so
there's also this really good lesson about product development if people are watching, because some of the people in our audience, they are entrepreneurs. So see, we really wanted to show off the technical pieces here, and things are moving so fast that we didn't want to wait a month to release the product. And by asking for this email kind of interface, we got rid of all the photo management related things, right? You just get an email, right? And we don't have to display the images anywhere. We don't have to do any of the other things. We will add all of these things over time, but you can see how rapidly iterating on the product helps right here. It's a very simple interface and you're done. You see the results. And if we see enough, we are actually already using these things in our consulting services. And if you see this kind of thing taking off, we'll add all these things, all these user interface thing, right? And of course, this also allows us to directly talk with the customers. There are some big customers who may not need the user interface, and we can still deliver the product to them. So kudos to you, Anna, for this idea of rapid iteration.
Thank you.
Yeah,
so
it's very cool. There's sorry to interrupt you again, Anna, but there's a couple people asking in the chat. The website is KopiKat, KopiKat.co. So if you want to check that out during the show right now, you can go do it right now.
Are you going to tell the story about the name later on, Anna, or is it?
Sure. Yeah, let me show you the next image in the meantime. So I'm just going to show you a couple of examples, and it also has this KopiKat logo so that you don't have to memorize. I was thinking about a name to name this product, right? That allows you to kind of copy and recreate the same image in the different styles, different environments, and types of lighting. And I was talking to ChatGPT and asked it to recommend me a good name for this service. It recommended me a couple of names. I said they were not fun enough, and it recommended me to call it KopiKat. So this is the story behind it. Thanks,
so it's a very meta thing, right? You're using you're creating a generative data augmentation tool using text-based generative AI, right?
Exactly. Okay, so let's look at the next image. It's a city with cars, with some buildings, and I again want to augment with it this data, for example, for autonomous driving or car monitoring system with different environments. And here's what I got from the service. Again, winter, rainy day, completely different colors, different type of lighting also. And this one probably from autumn. This one too. So it also works on different types of images. It works on any types of images. Let's see what it gets for this yoga type of data.
Wow.
Notice that there was a dog here and now there is a cat here.
A pretty large cat as well.
Yeah, this one, more cats, and this one.
Oh, the cat has like a leaf down that one.
Yeah. Oh, sorry.
So one thing, people, is the identity of the person changing? Is she different person?
It's a different person. The identity is not preserved in this scenario.
Yes, I mean, that's actually good, right? Because that maybe you'll talk about it later. I don't want to steal your thunder.
So the idea, we want to make data as diverse as possible while preserving the data annotation. And I was going to talk right about that. So the value behind this service is not only in generating different images in different environments, but also in saving the time while annotating the data. Now, imagine that we annotated key points on this person, right? To be able to recognize this asana in yoga, right? We would not want to just generate, loads of other data with other girls that are doing the same asana and having to annotate all of the data. We want to be able to reuse exactly this annotation that we already did. So this, as you notice, preserves the position of every element on the image here, which allows us to only annotate this data once and then create a lot of copies from the same image. Now, let me show you just a bit more examples of that. So this is a complex scene with a kid. This is an image from Coco dataset, and I'm going to talk a bit about Coco. So Microsoft Coco, as you probably know, is one of the biggest and most important benchmarks in computer vision. And it's used in different tasks, but I'm going to talk about object detection. So here for object detection data annotation, MS Coco has chair, sandwich, couch, and a person here, right? So we basically want to create the same kind of image with the same objects, right? But we don't want to re-annotate. We don't want to recreate the work that was already did by Microsoft when they created MS Coco. So KopiKat allows you to do exactly that, right? You can notice that the kid is there, the couch is there, the sandwich is there too, right? So we can actually reuse the same data. The same goes about other types of objects like elephant here, cat, another cat. We are going to have a lot of cats in our video today. Motorcycles. Notice that these are different images, but they both look very valid, right? And are good for training and are already annotated. So this is actually what brings you really, really closer to production with a smaller data set, right? So you take smaller data set, you multiply it with KopiKat, and you preserve the annotations that you already did, you're done. Notice that this kid has this funny hat, right? And the generated kid also has a funny hat like that, right? So the semantics is also here. The umbrella, the box for umbrella is correct. The box for person is correct, and it's tight, which is very important for training. It also works very well on furniture types. So this is the original MS Coco image and its annotation. This is what we get.
Wow.
On smaller objects like tie, it also works, right? This image also works. And on smaller, this is the original image. We have several apples, we have spoon, we have oats here, right? And it preserves even the spoon. So we are good to go with the original annotation from MS Coco, but we have a completely different image, different apples, everything. So this brought us to the next idea. How do we prove that, okay, that is great, right? So it preserves the data annotation. It generates completely different objects. sometimes it's weird about, it can generate something like some weird looking face or some weird looking hand, but the semantics is there, right? So how do we understand that we are good in terms of it helps train neural networks? So right now, and I mean, literally right now, we are working on experiment on a Mescoco. So we took a neural network that we are using in production a lot, that is called YOLO-X, and specifically its smaller version that is called YOLO-X Nano. You can go to GitHub, it's a completely open repo. Good thing about YOLO-X is, unlike other versions of YOLO, like YOLO 5 or YOLO 6, YOLO 7, some of them don't have commercially license that is good for commercial use. Instead, we chose YOLO-X Nano, YOLO-X family, because it's good for commercial use and it's very generalizable. It's very good for edge devices too. So YOLO-X Nano is something that we like to use on, for example, Jetson type of device, NVIDIA Jetson. So we did not change a thing in its code. We just took it directly from GitHub, and we tried training it in multiple combinations. So let me show you first this table. So we first took 5% of MSCoco, right? MSCoco is a very big data set. We don't want to train it right from the start, from scratch, the full data set. So we, again, took the iterative approach. First, we just took 5% of the MSCoco data set and trained YOLO-X right from YOLO-X Nano, right from the repo, no changes. We got 7.25 MAP, which corresponds to what the authors are claiming in their paper. 7.25 is a low number, but remember that it's the strictest number. It's a stricted amount of it's a stricted intersection of reunion setting, and it's like the percentage that YOLO-X Nano receives on 100% of MSCoco data is 25 MAP. So on 5%, it's okay. That it's a right metric that we got. That's 7.25 MAP. We augmented it with KopiKat, this 5%. And we created like the same amount of data as in this 5% of the data set. From this exact data, we created copies, right? And we call it 1x. So we trained 5% of the data set plus 1x augmented data, and we got 8.3 MAP with 0 changes in the code, right? Then we saw that this experiment is successful, and we decided to go further. We took 25% of the data set, and we got 17.5 MAP with no changes right from the repo. We augmented it with 1x, and we got 19.1 MAP. This is a super fresh result that we got yesterday. And right now we are generating the 1x copy for 100% MSCoco to see how it performs versus the same setup as the authors did in their paper for the full data set for the full MSCoco. So far, the experiments are showing that you apply literally 0 code changes, you generate data with our service, and you just get better network. And this is it. And this change is substantial, right? So here we did nothing, right? And we got almost 2% MAP. So we got 10% better model than we did before. It was also important for us that these plots that you can see here, every point of the plot that corresponds to our experiment with augmented data is above the plot with no augmented data. So the plot, the blue one is our experiment that we did with augmented data. The darker one doesn't have augmented data there.
Right.
So
and this is important because it shows that it is guaranteed to be better. It never gets worse, right? It's guaranteed to be better, which is a big deal, because sometimes what happens is that you are actually making a trade-off, right? That, it got better in some circumstances, but it got worse in other circumstances. But here, this curve shows that it is guaranteed. You are always better off using the augmentation that we are suggesting.
Yeah, exactly. So we intend to open source the code that we used, and all the data set, like the full data set, augmented data set, is going to also be open sourced. and everybody would be able to confirm our experiments and enjoy these, better versions of the same networks that we created in these experiments. So I'm going to show you just a bit more examples like that. So you can see this animal here, right? This is the results that we got.
Wow.
So these are the intermediate results from the KopiKat, and probably if you have some questions, we can answer them. If not, I'm gonna talk just a bit specifically about specifically about just a bit different algorithm that we are going to show today also, that is targeting sport and understanding how people look and how people move. Pulse detection.
Yeah, well, I mean, we've got a couple of questions here if you want to answer a few before you continue.
Yep.
Steve Simpson would like to know what's the plans for the business model for KopiKat?
Yeah, so basically we are going to charge per every image for which we generate copies, right? It's going to be a small price for every image. If you are interested, Steve, I encourage you to write us at KopiKat@opencv.ai, and we would be happy to provide you with 3,000 images to generate. And everything else will be for some small fee.
And it is a KopiKat with an I and a K.
KopiKat.
Just right, just like on this slide, right? KopiKat@opencv.ai.
Yeah.
We've got another question here about folks are asking, are there any plans to make it so folks could run this service locally, perhaps, or like on their own infrastructure?
Yeah, I was actually expecting a question like that. Thank you so much. It's a great question. So yeah, we have these plans, but they are not immediate, right? First, we are super interested in making sure that people can use our service through the cloud. But we totally understand that some types of data people don't want to, or even actually cannot, for example, some, very personal images, they will need to be, done offline. We would be happy again to discuss it. I encourage you to write us at KopiKat@opencv.ai to discuss that need.
Yeah, excellent. There's quite a few folks asking in the LinkedIn chat and here on Zoom about using this for medical data. Has there been much thought paid to that so far?
We actually tried using it for one medical case that does not. So it's applied for medical infrastructure, I would say, right? Something that is happening in the surgical room, but not to patient. And it shows that it's applicable, definitely, for sure. We did not apply this service for specific photos of patients yet. And the reason for that is to evaluate the, how valid the resulting images are. We would need a doctor, we would need a medical professional to do that. So we are interested in that, but we did not apply that yet.
Yeah, and we have to approach with a lot of caution. Medical data, hallucinating medical data, it is a recipe for disaster, right? Unless it is done very, very, very carefully with the help of under the supervision of doctors, etc. So, I mean, right off the bat, I would not recommend this for medical, you should not use it for generating new lung X-ray data that can, even if it looks like it's, I don't know whether it even looks like it's working, right? But even if it has the appearance that it is working, it is an extremely dangerous thing to do, right? So yeah, I would not recommend that we use it. There was one other question, Anna, about segmentation. Does it preserve segmentation annotation?
Yes, it does. So as you were probably able to see on the previous images, let me just go back a bit. So look at these images. They do not only correspond in their bounding box positions of the objects, but they also correspond in their pixel to pixel positions of the objects. Same goes here. And because of that, the segmentation masks of Coco are directly applicable here.
That's awesome. Yeah.
There was also a question about the license of Coco. The license of Coco is like it can be used for commercial purposes as well as Yolox Nano. So the combination of these things, when we release it to production, would be able to, so people would be able to reuse it for their own commercial purposes.
Makes sense. Yeah, I think that's enough questions for now. Yeah.
Let's go further. So I was specifically interested in analyzing images like that. So in OpenCV.ai, we worked with a huge number of algorithms and use cases that are related to sports. People want to understand how the athletes move, how they train, how they perform, to incorporate this information to their training, or encourage people to train more at home, or provide them live feedback, like you are doing this wrong, you should be having this position instead of that, your angle is wrong, you're going to harm yourself. So there is a like well-known state of the art in this area that a lot of people are using, that is media pipe place pose. But what we find out in several projects that we did there is that in many corner cases, which are related to sports activities, for example, when people are doing plank or push-ups or pull-ups, it would not perform as accurately as we expected to be able to provide live feedback like that, right? You won't be able to recommend to, hold elbow here and there based on the outputs of the state-of-the-art neural networks, any of the state-of-the-art neural networks, because the state-of-the-art neural networks do not know about quite a lot of the positions of human body, it seems. And for me, it's not a good thing, because it actually a lot of different business use cases depend on this kind of building block, right? Not only sports that I already talked about, but also AR, VR. More and more people want to digitalize the movements that they have. For example, a lot of people use VR chat in Steam, right? Where people can communicate with their friends and other people in VR spaces. And they want to move in this VR space, just like they do in their room when they're standing there in VR glasses. Right now, this is solved with hardware. Like you basically clip some small chips to your body. And there is a tracker that tracks the movements of these chips and digitalizes that. You are able to recreate your movements. But what if we're able to do it on our own using technology like KopiKat? So what we are doing here is a slightly more complex pipeline, because from our experience, it's not only important to create more images like this one, just like I showed you before, right? With a girl that is doing yoga and there is a huge cat or dog right with her. It's also important to cover different angles, different view angles. And this is exactly why the performance on different neural networks was not satisfiable, because if you use specific view angle, they perform great. But once you change it and put the camera higher or lower, they do not perform as well. So what we did here is we applied KopiKat in a more complex scenario to change the position of the camera while preserving the pose of the person, just like that, or that, or that. So notice they are all in the same pose, but the camera views are different. They all have different, like they look differently, but they are in the same pose. A different example. You can see that, yeah, it's a completely different images, and they are all valid from the, they are taken in a sports environments kind of environment, right? But the same pose.
Is it the same pose from different viewpoints completely?
It's the same pose from completely different viewpoints.
But the annotation obviously will not be preserved, or we are able to regenerate the annotation.
We are able to regenerate the annotation.
Wow, that's really.
I'm gonna show you how we do that. So we took this image and we annotated it like that, right? Now we created the same environment in 3D space, rotated the camera, and got a different type of girl here with different height, weight, or appearance. This is just the same pipeline that we did here. So in this image here, we just did the same. We annotated once, and we were able to recreate using our knowledge of 3D position of the person. We are able to do whatever with the camera position because now we know everything about the position of the person in 3D. Same goes here. So we annotated this image with 3D model of a person, rotated the camera, made it further from the person, but we know everything about this person here. MS Coco style key points in 3D, or even full position of the full body. This is what we do. So you can actually have a sneak peek at this technology and upload your image to test it at pose.kopikat.co. So we are not publishing it yet, and you're going to see it in OpenCV's newsletter just a bit later. But it's like a very, very new technology that we are showcasing. Again, you can try it at pose.kopikat.co. You can upload an image and get results on your email.
Neat.
Yeah, this is almost, we are in the future.
So this is all that I was going to show today. I would be happy to answer some questions.
Yeah, we've got a bunch more questions here. Before we get to that, I guess we should take this time to do our giveaway. You can go ahead and mind unsharing your screen there, Anna?
Sure.
All right. Yes. So, KopiKat, super interesting, exciting new tool for generative data augmentation. As Satya said before we started today, it's buzzword compliant, folks. We're gonna do our giveaway here. So if you're just joining us or you need a reminder, one of the things we do on this show is give away something to you in the audience every week. This week, we talked a little bit about different data augmentation methods and data sets and stuff like that. If you want to participate in our trivia giveaway, the best way to do that is to go to opencv.live and hop in the Zoom chat. If you're already in the Zoom chat, then you're ready to go. I'm going to ask a trivia question, and the first person to answer that question correctly in the Zoom chat will win the OpenCV course of their choosing. You can go to opencv.org/courses to see what courses are available, and this does include the Mastering AI Art Generation course, which is releasing imminently and is currently available on Indiegogo. So get ready to answer. This one is a two-parter. If you have won in the last 2 months, please do not answer. Give someone else a chance to win and spread the knowledge and whatnot. If you answer before I'm finished asking, I will disqualify you. I'll do it.
So you cannot.
So during it's a two-parter. So you got to answer both in the same answer. Do not post twice. Just one message. We've talked a little bit about the COCO dataset here today, MS COCO. What does MS COCO stand for, and what year was the first version of the MS COCO dataset released? It's a two-parter. Answer both parts in the Zoom chat, and you will win the OpenCV course of your choosing. Oh, I think I finally got them.
Okay, finally. 1 second has passed and nobody answered.
They're close. They're close. Nobody's got it yet. The full name of COCO. What does MS COCO stand for, and in what year was the original version of COCO released? Folks are getting close. You're getting the name, but not the year. Some of you have got the year, but not the name.
All right.
Oh, our trivia shark Partha pops in there.
Trivia shark Partha.
You got it. The answer, Partha was correct here. The answer we were looking for, both parts, was Microsoft Common Objects in Context, and the year was 2014 Microsoft Common Objects in Context 2014. Congratulations, Partha. Please send one email to phil@opencv.org with the course you would like, and we'll make sure that you get access to that course in your OpenCV courses dashboard. If you didn't win, you can still learn stuff. Go to opencv.org/courses. Check out our affordably priced, professionally produced and created courses. So many people have taken these and really leveled up their careers. It's helped them get new jobs. It's helped them learn new things in their current jobs. Go check it out. It always helps to stay on the cutting edge, and we are that cutting edge.
So just to give you some context, this Partha is our OG of this, and the rule that that Phil has come up with, that you cannot win in if you win, then you have to wait for 2 months to win, was originally devised so that Partha doesn't keep winning.
Absolutely, that's the Partha
still unofficially after some time.
Unofficially known as the Partha rule. It's
right.
It's the thing. Congrats to the trivia shark. Dun, dun. We need a sound effect for that. So yeah, we got a few more questions here. Folks are mostly just interested in trying it out, which is, again, really awesome if they can just go to KopiKat.co and in 2 clicks upload an image and see what they get back, 6 images back in their email. Give it a shot. So Richard Young would like to know, are there plans to make it so you can provide, like the user could provide specific prompts or inputs to get the required or requested augmentation / generation, like user defined outputs essentially? Is that on the roadmap?
Yes, so we are actually thinking about that, and it is on our roadmap, that people might be interested in some specific conditions on their in their resulting photos, and technologically this is completely doable. This is exactly how we do it. This is basically how we can do it. The only question is, what would be the best UX way to do that on the site or some console? I don't know, right? So what's the best way to input that? However, again, if you need some specific things for us to do around the data set, just write us at KopiKat at opencv.com and opencv.ai, and we would be happy to do that because we have the technology to do that now.
We have the technology. We can rebuild him. Yes, and don't forget there's that pose. I didn't even know that thing existed. The pose estimation version. Very exciting stuff. Yeah, very exciting stuff. Speaking of exciting stuff, OpenCV will be at the Embedded Vision Summit next month here in Santa Clara, California. Booth 1008. In fact, you can join us there by registering today and save 15% at embeddedvisionsummit.com by using the code OpenCV. That will save you 15%, but you only have until Friday to lock in that savings. So hit up embeddedvisionsummit.com. Come join us here in Santa Clara. It's right across the street from the 49ers Stadium, which is confusingly several miles outside of the city limits of San Francisco, California. But sorry, 49ers. Did I say Giants? Oof, too early in the morning for sports.
One more thing is next week I'm going to be visiting and I'm going to be speaking at Embedded Machine Vision Alliance Conference in Sevilla, Spain. Come say hi if you're there.
Yeah, awesome.
So we have three venues. One is in US, one is in Spain, and the last one is in at CVPR Vancouver. It's Vancouver, yeah.
Yeah, this year CVPR is in Vancouver, BC. OpenCV will have a presence there at all three of these events. I probably won't be at any of them except for Embedded Vision Summit, but Satya should be at least 2 of them, right? We may.
Yeah, yes. I'm not going to Spain, but yes.
Yeah, we may even people may even have a chance to see the famous cryptid Gary Bradsky, who leaves his cave once a couple times a year to forage for nuts and berries. I think he will be at the at the Embedded Vision Summit, so go say hi to Gary. We got a couple more questions here in the LinkedIn chat here. Folks are asking, is it possible to upload a batch of images and get, batched versions of those images back, or is it kind of one in, one out currently?
So we are enabling batch version very soon. So far, we will be able to do that only just write us email. We already can do that. We just did not implement it in our front end yet. We can work with like buckets or Google Drive, whatever works for you guys.
Excellent. Let's see here. Folks were asking if this session will be uploaded anywhere afterwards. Absolutely. This will go on our YouTube channel. It's youtube.com/@OpenCVAI, all one word there. I'll post the link in the chat as well. These always show up in that playlist. There's the link for all you good people. So that's where the recording will go, youtube.com/@OpenCVAI. Also, the best way to know when these recordings get uploaded is to subscribe to the OpenCV newsletter, opencv.org/subscribe. It goes out every Tuesday morning. It will have stuff like this, interesting news about releases. For example, the OpenCV newsletter audience were the first to know about KopiKat last week. It's also the best place to learn when we do new competitions, when new versions of OpenCV are released, stuff like that. So go check that out at opencv.org/subscribe and join the 65,000 subscribers to that newsletter. Let's see here. Looking back through our Zoom chat. I mean, I've got a question which is more, my background is in web development and like designing web services and databases and stuff like that. And I'm interested in how this works on the back end. Like what systems are used to deploy this system, and kind of how is it wired together in the back end?
Well, so far it's like pretty simple, again, because we decided to not, build, huge system from scratch and then find out that people are not interested. So we are taking this iterative approach, but we are using Google Cloud Stack very much, right? So we love Google Cloud Stack and we are using that.
Nice, yeah. And so obviously, since it's how many people are currently working on the service, like from the OpenCV AI side?
3 people.
Okay, wow.
Yes,
we like
like
to
the
say
whole project is technically created by 3 people.
Yeah, that's awesome.
Side.
About how long did it take before? So when people finally, when they open up their IDE and check it, in it repo. How long from initializing a repository to deploying this? How many days or weeks was it?
I mean, you write us to on our email, right? For example, you send us 1,000 images in like S3 bucket, Google Cloud bucket, or Google Drive. We will send you the generated copies of them not later than in 24 hours, and you're good to go, good to train.
It's pretty impressive turnaround for sure. Let me get a couple more questions here. People are asking, is OpenCV.ai hiring right now?
Well, I'm flattered, but not so far. So far, we are keeping this team pretty small, but very, very agile. Yeah,
definitely. And you can go to OpenCV.ai and submit the contact form if you're a skilled computer vision or AI practitioner. It always helps to reach out, but as Anna says, there's not really any plans for hiring at the moment, but always helps to say hello.
Actually, we are looking for a business development person on OpenCV.ai consulting side. So if you feel that you are the right person, we would be super happy to talk to you.
Yeah, all right, BizDevers, get at us. You can send that form at opencv.ai. It's just a couple of taps to contact the team there.
Yeah, contact at opencv.ai is the right email, or you can use the form on the site.
Yeah, excellent. Let's see, I'm reading back through here. Yeah, so are there any ways to, this is sort of a complicated question, but are there any ways or any plans to make it so the users of this service can explicitly choose what does and does not get augmented in this data?
Yeah,
like
that's
if they
possible.
say keep the person the same, but I want them to be wearing a different shirt, and that's the only thing that changes, that sort of stuff.
Again, on the technology side, it's possible. The only question is how do we do that in the UX? And to implement this in the UX, we basically need to hear your thoughts, guys. If it's a feature that would really help some people, we are adding it to the site.
Yeah, it's always it's the engineering aspect of these things that make them difficult, not the it's the usability that makes it hard. It's not the technological roadblocks, because there really aren't any. It's just what is a good way to do it to make it so it's useful for people. And it's always the hardest part. Yeah, and we're getting pretty close to time here. Satya, you got any other things you want to clue the audience into this week? Any special events? I know we had originally, I think we'd said that the Mastering AI Art Generation course is supposed to go live in sometime in May. Is that still the case?
That is still the case. We'll do it in steps. We will release the first course. There are two courses, AI Art Generation for Everyone, which is going live in the first week of May. And the second one, it will take a little bit more time, but that's the one after the other.
Yeah, definitely. Yeah, so folks, I mean, it's been a fun one. Anna, you have any final thoughts for the audience here before we call it a day?
Well, thank you so much, guys, and thank you for the warm response that we hear for KopiKat. I'm actually super excited to be presenting it for the first time. And please let us know what other thoughts you have after receiving the images or generally. So we would be super happy to just talk and chat about it. Thank you so much.
And also help us publicize. We will start. This is the first time it has been demonstrated publicly, but once we start doing our marketing on LinkedIn and others, please help us out. This will help us greatly.
Yeah, definitely. Thanks so much for joining us this week, everybody. We'll be back next week. I think we're going to be talking about drones, something about drones maybe. Same bat time, same bat channel, 9 a.m. Pacific time, Thursday morning. I'll be there. You should be there too. Come say hi again next week here on OpenCV Weekly. This was episode 101 in the can. I am your co-host with the co-most, wishing you a great day wherever you may be.
All right. Thank you, guys.
Thank you so much. Bye.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.